Hello, my name's Steven, and for my final project, I built a dog babysitter. This is how it works. So we've got a Raspberry Pi. It's controlling an Arduino. The Arduino has a driving sensor that kicks off the entire process. This is a microphone. It's on its own little breakout board. It has a condenser. I don't know if you can see, but that little brass screw on top of the blue box can control a bit of sensitivity. That is a condenser mic. So what it does is it takes that input and it's going to digitize the output. If that output falls within a threshold level of activation, then it's going to activate the piezo speaker that we have. I still have an LED in the setup just to see if it's being activated without one or another component then working in series. So you will see that light up, and you will hear that make a noise, and that is basically a audio correction for a dog barking. That's the level of sensitivity. It's pretty high because dog barks are pretty loud, and I live in a pretty small place, so it echoes. So once it issues that tone correction, it inputs a delay, and then finally we'll activate this servo. You'll see that servo rotate between positions like that, because that would be in effect dispensing the treat for the dog. So we're going to go ahead and reset our system here. The first thing you'll see is that servo returning to a 0 position. After we get that running, that is the 0 point. And from here, this is now running. So we had to include a library for servo control, and that was, getting through it after reading through the documentation was not the most horrible thing to implement. From there, we had a bunch of variables that we had to declare. One was for the microphone and what pin it is operating on. That one is being controlled by a analog pin, number 0. Next, we have a one pin controlling the buzzer. That one is digitally controlled. We are declaring that our buzzer is also working off 3, which is a different control mechanism for that same buzzer. So we're using 2 different controls for the buzzer. From then, we're importing servo from servo library. We need to get that saved. We have to implement our position to 0, and that's what you saw when that servo first started to move. So from there, we messed with the clocking of the Arduino system itself, and that's what this represents, this timer now being set to 15,000. So to go through, we are digitizing the output of our microphone. We are assigning it a number value, and so that number can be in a low range or a high range, and that is just called output here. So what happens at that point, we're looking for a very specific range. Again, a dog barking is a fairly loud noise, and so that's what we're most interested in. We don't want the thing dispensing treats at every door close and thump on the carpet or what have you. This again comes from the servo library, where we are attaching it to digital pin 9 for its control. Here we have to set variables for the minimum and maximum levels that we want to pay attention to with the microphone. We have a slight delay. Here we are reclocking the timer to start the loop itself. Now here we are iterating through a range. We are again assigning those numbers from the microphone to a range between 1 and 100. Incrementing by 1, and that's going to output the minimum and maximum values. So we go through and we declare that variable. So now we can set our sensitivity with just one entry here. So if we are going to do 200, that seems to be pretty good. The higher you go on this, the louder the more sensitive it is. So the higher number represented here, the more sensitive, and that'll go down as far as 50, but it's It's kind of a pain after that. So delta is what we're calling our microphone output. Now, from here, if we detect that the microphone is outputting a number within the range that we are looking for, then we use this function, this digital write, to activate our speaker. We're calling that the high range of the speaker because we don't want it activated in the low range. Again, we're not listening to everything that goes on in the house, just what happens when the dog is behaving in a way that we don't like. So here is what decides the sound of that buzzer. Buzzer is our variable. 50 is the hertz range that is operating in, so it's fairly low. This is the duration, so about 3 seconds. And then we're changing our timer clock again. So now that timer clock is guiding the remaining functions of the program. If that timer has decided that it has been reactivated within that range, then it will skip this entirely. Dog gets no treat for repeatedly barking because that's just not something I want to deal with. Now, if it's less than that value, we detect the position of the servo motor. If it's in the right position, we go ahead with the movements. If it's in the wrong position, we reset. And this is what that looks like all put together. We're going to reset this. Again, microphone, piezo speaker, and our servo. So now that this is on, we should be able to see that was a dog barking, or a close approximation to it, because I do live in an apartment. I'm not going to bark to test this. So that microphone had not been reactivated within 15 seconds. The servo does go off to dispense the dog a treat. Now, what you're going to see is that servo returning to the 0 position. It's going to wait for a longer period of time, a much longer period of time, because again, we don't want to train the dog to bark. That's what we're trying to avoid. So that will come on at varying intervals, again, set by reclocking the onboard timer of the Arduino. And that'll run consistently, unless we do this. And then it all stops.